Hello science fans. Today let's talk about robots that can actually think, not just follow commands but reason about their actions. DeepMind, a leader in artificial intelligence, is working to make this a reality. Their goal? Build machines that learn and solve problems just like us. Imagine robots with an inner voice, a way to talk themselves through tricky problems much like we do. This is a huge leap. Robots that can adapt, learn from experience, and understand what needs to be done. For years, robots repeated the same task over and over, like a factory arm. But what if the task changes? That's where DeepMind's work comes in. They're teaching robots to reason and adapt, not just follow scripts. This inner voice is a game changer for artificial intelligence. We'll explore how it works, why it matters, and what it means for our future. How can a robot learn to make a sandwich by watching a video? How does self-talk help it understand the steps? It's all about making technology work better with people. Understanding the science behind it is the first step. So, get ready to dive into the world of thinking robots. Let's see how robots are becoming more like us, one thought at a time. Ready? Let's go. What's an inner voice for a robot? It might sound like a strange idea at first, but it's actually a fascinating concept that's changing how robots think and act. Think about when you talk yourself through tying your shoes. Make a loop, go under, pull tight. That's your inner monologue, quietly guiding your actions step by step. Scientists want to give robots a similar tool, a way to talk themselves through tasks, just like we do. For robots, this voice is a stream of text inside their computer brain, a running commentary that helps them process what's happening. For example, a robot might say to itself, "I see a cup. The cup is empty. My goal is to clear the table, so I need to move the objects one by one. I should pick up the cup and place it in the bin." This self-talk connects what the robot sees to what it needs to do, helping it make sense of its environment and plan its next move. In the past, robots followed rigid step-by-step code. If anything changed, they got stuck or failed to adapt. With an inner voice, robots can now observe, reason, and adapt in real time, adjusting their actions as situations change. This is powered by large language models, AI that can write, answer questions, and translate, giving robots a new level of understanding. DeepMind connects these language models to a robot's vision and actions, creating a powerful feedback loop. The robot turns what it sees into words, then uses those words to decide what to do next, almost like thinking out loud. It's like giving robots the ability to reason and plan using language, just like us, making them more relatable and capable. This makes robots flexible and able to handle new situations, even ones they've never seen before. It's a big leap from the old days of rigid programming, where robots could only do what they were told, nothing more. Now, robots can create their own instructions as they go, learning and improving with every task. That's the power of an inner voice, a silent guide that helps robots think, plan, and act. It's a bridge between seeing and doing, turning perception into intelligent action. And it's changing robotics forever, opening up a future where robots can truly understand and interact with the world around them. So, how does a robot actually see the world around it? And how does it begin to process what it observes? And how does it start its own inner conversation, almost like talking to itself? It all starts with cameras. These are the robot's eyes, capturing a constant stream of images and videos from its environment. These images are sent to the robot's AI brain, which has been trained on massive amounts of data from the internet and real-world experiences. The AI then connects what things look like with the words and concepts that describe them, building a mental map. For example, when the robot looks at a kitchen counter, its inner voice might say, "I see a red apple on a white plate. There is a knife next to the plate." It's describing the scene to itself, step by step. The robot isn't just seeing colors or shapes, it's identifying objects, understanding what they are, and figuring out how they relate to each other. Next, the inner voice considers the goal at hand. My goal is to tidy the kitchen. The apple should go in the fridge. The knife goes in the drawer. It's planning what needs to be done. The robot uses its knowledge and reasoning to make logical connections, mapping out a sequence of actions to achieve its goal. As it acts, the inner voice keeps track of progress. I have grasped the apple. Now, moving to the fridge. This ongoing narration helps it stay focused. If it fails, the inner voice notes the mistake. My grip slipped. I should try again. It's aware of errors and ready to adapt. This ability to self-correct lets the robot learn from its mistakes. No human reprogramming is needed for every little error. It's learning on the job, just like we do, improving with every attempt and every new experience. The inner voice is crucial. It helps the robot observe, plan, act, and then reflect to improve for next time. This is what makes robots smarter and more adaptable, able to handle new situations and unexpected challenges. It's not just about seeing, it's about truly understanding, reasoning, and making sense of the world. That's the real breakthrough in robotics. Robots are starting to think for themselves, making decisions without waiting for human instructions. And that's a huge step forward for technology and for us all. The future of robotics is here, and it's only getting brighter. Let's see this in action with a simple example. Teaching a robot to put a cracker on a plate. This might sound easy, but for a robot, it's a complex task that requires understanding, observation, and adaptation. Instead of coding every single step, we simply show the robot a video of a person doing the task. The robot learns by watching, just like a human child might learn by observing an adult. The robot's camera carefully watches, and its inner voice starts describing what it sees. A hand reaches for the cracker box. The box is opened. A cracker is taken out and prepared for the next step. The robot translates these visuals into a clear sequence of steps it can follow, breaking down the task into manageable actions. Next, it plans. My goal is to put a cracker on a plate. First, I need to locate the box on the table. Open it carefully. Then, take a cracker out, just like the human did. Place the cracker gently on the plate, making sure not to break it. The robot follows its plan, narrating each move. Moving arm to box, touching box, preparing to open. If it accidentally pushes the box instead of opening it, the inner voice helps it adjust. That didn't work as expected. The human used fingers to open the flap. I should try using my fingers in a similar way. This ability to self-correct and try again is key to real learning and improvement. The robot gets better with each attempt, learning from every mistake and refining its actions. It's not just copying, it's truly understanding and adapting to new situations, making decisions on the fly. The inner voice is what turns simple observation into meaningful action, guiding the robot step by step. This is how robots can learn new tasks quickly, often after just a few demonstrations. It's a smarter, more human-like way to learn, making robots more flexible and efficient. No endless trial and error. Just a handful of demonstrations, and the robot is ready to go. The robot figures it out, step by step, building confidence with each success. That's the magic of an inner voice, helping robots think, learn, and grow. And it's only the beginning. The future holds even more possibilities as robots continue to learn and evolve. Why is self-talk so powerful for robots? Because language simplifies complex ideas. Instead of millions of pixels, the robot's inner voice says, "First, get 2 slices of bread." Language helps robots focus on what matters. It also helps them generalize, apply what they learn in one situation to another. A robot that learns to put a cracker on a plate can later put an apple on a cutting board. The inner voice makes its reasoning visible to humans too. If the robot makes a mistake, we can check its inner monologue to see why. This makes debugging and teaching much easier. Robots can learn from just a few examples, not thousands. Language gives them context and structure. It's like understanding the formula, not just memorizing answers. That's why the inner voice is such a breakthrough. It's the secret to smarter, faster learning. So, what's new about DeepMind's approach? They combine computer vision, language models, and robotic action into one seamless system. Before, these were separate fields. Now, they work together. Robots can see, understand, and act all at once. This means robots aren't stuck on rigid paths. They can adapt and make decisions. They learn from the internet, videos, text, and human knowledge. Teaching robots is now as simple as showing and explaining, not coding. Anyone can teach a robot a new skill, not just programmers. This makes robotics more accessible to everyone. It's a revolution in how we build and use intelligent machines. What does this mean for us? Imagine a home robot that understands, "Please tidy up the living room." Its inner voice guides it. "I see toys, put them in the toy box." Magazine on the sofa, move it to the table. In schools or labs, robots can learn new procedures by watching and listening. On job sites, they adapt to changing environments, making work safer and more efficient. For the elderly or people with disabilities, robots can help with daily tasks, understanding preferences and context. The key is adaptability. Robots that can reason and adjust, not just follow scripts. They handle the unexpected, like a missing object or a person walking by. This makes robots truly useful in real homes, schools, and workplaces. It's a leap from factory floors to everyday life. Smarter robots mean more independence and support for everyone. The future is about helpful, adaptable robot partners. and it's closer than you think. Let's bring it all together. DeepMind is teaching robots to think out loud, combining vision and language to plan and learn. This inner monologue turns messy images into clear step-by-step actions. Robots can learn from videos, generalize, and solve problems, just like us. The possibilities are huge, helpful robots at home, in labs, and in hospitals. This technology frees people for more creative work. The future of robotics is about collaboration, not just automation. Robots will learn new skills by watching us, making them easy to integrate into our lives. Today's breakthroughs are building a future of smart, helpful robot partners. The age of thinking machines is here. The inner voice for AI is more than just one robot learning a task. It's a shift in how we relate to technology. Now machines are learning our language and our world, making tech more natural and powerful. This breakthrough applies to all kinds of AI, not just robots. Imagine an AI that explains its decisions in plain English, building trust and collaboration. But with this power comes responsibility. We must ensure safety and ethics as AI grows smarter. Building safeguards is as important as the technology itself. Teaching robots to reason helps us understand our own minds too. The inner voice is a mirror to human intelligence and curiosity. The future will be built by humans and smart machines working together. And it all starts with that little voice inside asking, "What should I do next?"